All right. Hello, everybody. Thank you for coming to our fourth BRR training session on creating steel structures in BRR. Um, I don't have too much to add in the beginning from here, so I'm going to hand it right off to Pro Miles and let them introduce themselves and take it away. So thanks, everybody.
Hey, thanks, Sean. All right, so my name's Carolyn. I'm a technical manager with ProMiles. We've also got Mark and Jeff on the call here.
Hello, everyone. Go ahead, Mark.
My name is Mark Belnarski, and I'm a technical manager and support manager for BRDR for ProMiles.
And I'm Jeffrey Trees. I'm also on the project. I act as a technical manager. So nice to be here. Carolyn?
Yes. Again, so all right, so we are going to be doing, like Sean mentioned, we're going to be going through the training on creating a steel bridge from scratch here. In the previous training, we were working with the template bridges for the two, but this tutorial is going to go through creating the new bridge from scratch. Oh, sorry, let me share my screen. Okay, I think you should be able to see my screen. So for this training, there was a tutorial that was sent out here. This is the steel two-span plate girder tutorial. So this is what we're going to be working with here today. So if you've had a chance to look at this, the first couple of pages here just include the info on the bridge that we're going to be modeling. So we've got the section with dimensions here and framing plan, as well as the girder profile here. So this is what we're going to be creating in BrR here. All right, so to get started in creating a new bridge, we'll go into the Bridge Explorer here and click New to create our new bridge. Again, I would encourage all of you to, follow along with the training here, and we will answer any questions you have and everything. One other note, just as we're getting started here, there was an email sent out with temporary licenses for the training. So again, if you want to use that to follow along and go through this, that would be great. Just make sure that if you are doing production work during the time those licenses are active, that you do it under your normal license, just because there are some restrictions on exporting from the training licenses. But we will get started here. All right, so when we are creating this bridge here, we can uncheck the box for culverts. All this will do is basically just hide the culvert definitions in the bridge tree here, since we won't be using that for this example. And we'll just go ahead and populate the rest of the info in this tab. And then the other thing just to mention here, so this example just is for, it's just a general example on creating a bridge. For all of these things, I would recommend referring also to the Iowa DOT documentation and templates, because there are custom agency fields and things like that that you'll want to fill out that'll be specific to Iowa DOT. That's not included in this example, but you'll want to make sure to reference that documentation as you're creating these bridges. All right, so this has basically created the bridge definition for our new structure. If you ever need to get back into that window, that's right up here at the top of the bridge workspace tree. You can always get back into this window from right there. So the first thing that we're going to do is create or define the components here that we're going to be using in this bridge. So we're going to start out with the materials, and then we'll create the appurtenances. So to do this, you can either right click and click new, or you can double click the tree here. For this, we're going to copy from the library. Here we can see all of the structural steels that are in the library. So we're going to select grade 50. We can review the properties here and then go ahead and click OK. So that copies this material from the library into this bridge. Okay, then we're going to go ahead and do the same thing for reinforcing steel. Going to select the grade 60. Again, you can also just define reinforcement. If it's not one that's in the library, you can just enter the properties directly and click OK, and that will save that material to this bridge. And then we will do the same for the concrete. And so you'll see here when we copy the concrete material from the library, we can review the properties here. If you did want to change the compressive strength to basically use a different concrete, you can always change this here, click compute to recompute these values and click OK, and that'll basically save a modified copy of this library item to the particular bridge that you're working on. For this example, we are going to use this library item as is. So the next step is going to be to create the appurtenances here. So we have this parapet. For this one, we're going to create the item here directly rather than using the library item. There is a library of standard appurtenances that was created by Iowa DOT. So again, if it is a standard appurtenance on a bridge that you're working with, I would suggest checking the Iowa DOT appurtenance library first. But for this example, we're just going to create a new parapet. Right, so we have the dimensions and the unit load for this parapet. We can go ahead and click OK, and we've saved parapet to the bridge model. So now that we've defined the components that we're going to use in this bridge, we can go back over to the bridge itself. You can see the components that we just created here are saved. And so to create the bridge, we're going to go ahead and double click the superstructure definitions. You'll see a bunch of different options here for types of superstructures that are supported in BrR. This is going to be a girder system superstructure, so we'll select that and click OK. So this is our superstructure definition window. I'm just see the chat here. We had a question. If the bridge does not have a parapet, leave it blank. Yes. So basically you would only need to create these components if you want to include them in your bridge. So yeah, you don't need to create that if we don't have it on that particular structure.
And Carolyn, one thing you could also mention is that the purpose of adding the parapet is so that the program can calculate the dead loads. You can also apply loads manually if you want to as well.
Yes.
So you have that. I do think though having the parapet, correct me if I'm wrong, Carolyn, but I do think adding the parapet, one of the advantages, it also helps calculate the lane widths, right?
Yes, exactly. So what the pertinence is, basically it'll contribute to the dead load on the structure, and then there'll be a window in here later where we assign it, and you'll see that it'll also then help to create the typical section. So exactly like you said, Jeff, so you can get the correct travel way.
It will also help once we have the IFC stuff. I know, Jim, we always talk about the IFC stuff, but if you just put the loads in for all of the objects on the bridge, then it doesn't know, it's just generic loads. Whereas if you start to use some of these other features, it'll have more information about the bridge down the road when we want to do modeling.
Yes. So yes, thank you, Jeff. All right, so for the girder system superstructure definition window, basically we're just going to enter the spans, girders, and span length. We're going to select the steel member alternative type. And then just also to point out a couple of other things that are in this window. We don't need to make any changes in here for this example, but this analysis tab will give you some options on modeling. And when you create these models, you are able to run the line girder analysis or the 3D finite element analysis, and this gives you some options here on how you can make some adjustments to that model. We also do, just to briefly mention as well, there's the specifications tab. So this will default to the most current version of the specifications that's in here. If for some reason you ever do want to, let's say, check a bridge that was built with an older specification, you can come in here and, pull previous versions of the specifications if you ever wanted to just kind of evaluate differences. All right, so so we've got the girder system superstructure definition set up there. And so once we click OK, you'll see it'll populate this part of the tree here. Again, you can get back into that window just by going here. All right, so then just to kind of take a quick look at some of these first couple windows here. So the impact dynamic load allowance, this allows you to modify the impact that's being used on this bridge. In a lot of cases, there wouldn't really be much of a need to do this, but it's here if you do need to. And then just to mention as well, so this is the impact. This will be used whenever you analyze this bridge. If you're looking to modify impact just for a scenario, like when you're running a permit vehicle and you want to use like a reduced impact for a specific vehicle, you can do that through analysis settings as well. We'll cover that a little bit more in one of the upcoming trainings. But this will be applied to the bridge if you change it here. All right, so the next thing we're going to do is look at the load case descriptions. So I think we're going to add default load case descriptions. Yeah. Wait 1 second. Okay. So I guess before we go further with creating the actual bridge, so in this example, it basically shows the next thing is creating the bridge alternative. You can do this at any point in time. You don't have to do it at a particular time. But just for the sake of following this tutorial, we are going to go ahead and do that now, kind of when we create this. Again, we've talked about this a little bit before, but the purpose with the bridge alternatives is basically to tell the system which superstructures you want included as the existing and current structure. And so that's what'll be used if you're running, let's say, a batch analysis from the Bridge Explorer to, let's say, check a permit vehicle or something like that. So this is basically telling the system, this is what we want to use if you're running a batch analysis, and this is the current bridge that's out there. So we're going to go ahead and create the bridge alternative here. Okay, then we expand the tree here and set the superstructure. This tab also includes some information here on vehicle path. So if you are running a non-standard gauge analysis, this is where you'll set that vehicle path information. But for what we're doing right now, all we need to do is just create the alternative. Click OK. And then we come down here, and this is where we'll select the superstructure that we want included. All right, so once we have this set up, it's basically telling the system that this is the current existing version of the bridge. In cases where you do have different alternatives, you can also go back into here, and now you'll see, or sorry, you go back into here, and you'll see in the bridge, it'll show your alternatives here, and it'll show that this is the alternative that's selected. All right, so we've set up the superstructure definition and associated it with the bridge alternative. Again, you can modify impact here in the event that you need to. Load case description, we are adding the default load cases. You can also create, custom load cases in the event that you need to do that. So the next thing we'll do is set up the framing plan. And again, this will be based on what I had showed kind of at the beginning here. There are some schematics and diagrams at the beginning of the tutorial that was sent out. So we're going to go ahead and enter the girder spacing. And the diaphragms. All right, so we have defined the diaphragms for this bay. We want to also set the same diaphragms in the other bays on the structure. So we're going to go copy bay. This is just asking if I want to save this. And then we'll select the other two bays we want to copy it to. So these are both highlighted now, and we'll click apply. And so this is just letting me know that the diaphragms are successfully copied. The one other thing to point out before we move on here, you'll notice that this example doesn't have information here for the diaphragm assignment. In general, you will want to add the load here, the weight of the diaphragm. So this is basically telling the program the location of the brace points. You will want to add in that load or create the diaphragm itself and assign it here. Again, you can look at the template models for some examples on how that's done for the Iowa DOT template bridges. So once we've set up the framing plan there, We can click OK to save.
I want to jump in real quick. I'm correct in the diaphragm definitions are required if you want like a non-standard gauge analysis or something, right?
So the non-standard gauge, well, yeah, so the diaphragms are required if you're running a full 3D analysis.
Okay.
Yeah.
That's a good question. I don't know the answer about non-standard gauge because I think the non-standard gauge, we do create a 3D model to determine the distribution factors, but we still actually do the analysis in a line girder fashion.
Yes, that's correct.
And I'm pretty sure to answer that question, Sean, I'm speculating here, so don't take my word for it, but the non-standard gauge feature has been around a lot longer than the 3D analysis. And so we added those diaphragms for 3D. So it used to, I mean, it worked before having that in there. So I'm pretty sure you do not need to define the actual diaphragms. You just have to have the locations like Carolyn showed.
Okay, thank you.
Yeah, but like you guys said, they are required if you're doing 3D and stuff. So,
Yeah.
okay. All right. So once we've set up the framing plan, you can right click on framing plan and click schematic. This will show the schematic here that you can review just to kind of ensure that things have been entered the way that you intended. Um, and then if you do make updates in this framing plan window, this will update when you click the apply button or OK button. All right, so next we are going to set up the structure typical section. So this is basically just defining the geometry of the cross section of the structure. So go ahead and enter this. All right, so this is just setting up the width and the overhang. On the deck tab, where we'll go ahead and select the deck concrete that we defined earlier in the library here, and we'll define the deck thickness. This deck thickness is used to compute the dead load. So sometimes if you want to consider part of that deck to be like sacrificial, there will be a point later when we define sort of the structural parts of that. So just this is used to compute the dead load. All right, so next we'll go over into the parapet tab, and this is where we're going to assign the locations of the parapet that we created earlier when we were setting up the components. So we'll click new, and we're going to pick the load case that we created here in the load case descriptions, and set up the position of the parapet on the structure. Um, then let's see. Okay, so this structure doesn't have median, railing, generic, sidewalk, but you could also use these tabs to define other appurtenances that are on the structure. So we do want to go over to the lane positions tab, and here we'll click compute. And so the program is basically using the information that we've already entered about the width of the structure and the position of the parapets to compute the width of the travel way for the structure. So we can review that and click apply. You can also just manually enter that information as well. So okay. And then I think the last thing on this tab is just to add the wearing surface. and we'll assign the load case. All right. Once we have set that up, we can review the schematic here. So right click the structure typical section and select schematic. This way we can review and confirm that these things were set up the way that we intended to. Again, it's easy to, for example, like get a parapet backwards or things like that. So this schematic is helpful just in terms of confirming that things are positioned the way that you want to. You can also like keep the schematic open while you're working in this window if you're like making changes here. So let's say, here, let me just move this. So let's say you have this and you realize your parapet's not in the right place. You can make these adjustments here and they'll be reflected in this schematic when you click the apply or OK button. And then the girders themselves here are just shown as a generic shape now since we haven't created those members yet, but that'll be populated once we've defined the members. All right. I think the last thing before we get to the members is to just create the stiffener definitions here. So for this bridge, we're going to use plate stiffeners. And we have the steel material. Since we've only created one steel material for this bridge, it's being populated here. But if you're working with a bridge that has different materials, you'd want to just select the appropriate one. Okay, then we will just create the bearing stiffeners. So, so we've set up the superstructure definition overall, and we're going to go ahead and create the member alternative now. For this example, we're going to do an interior girder. So we'll go to G2. And you can see here that as of right now, it's not showing an existing current member alternative yet, but we're going to go ahead and create that over the next few steps here. So for this example, we're going to add member load for stay in place forms. So we'll just open up the member loads window here and click new. We'll select the load case and add that load. And then we will go to the supports window. So this is defaulting to pinned and roller supports. So this is where you would set or change the supports based on the bridge that you're rating. One additional note is that if you are going to run a 3D analysis on this structure, you will probably want to review the 3D supports tab and just make sure that that's actually set appropriate for the structure that you're rating. So So we don't need to make any changes in this window, but this is where you would set or change your supports if needed. Okay, so then to create the member alternative for this girder, we will double click the member alternatives. We're going to select steel and plate. Go ahead and click OK. Actually, I guess maybe before we go too far, are there any questions so far? I'm trying to kind of keep an eye on chat here, but I want to make sure I don't go too far.
Yeah, I don't think we have anything in the chat right now, but just to reiterate what Carolyn has said about the 3D analysis, you typically don't do a 3D analysis unless you have a situation where you're trying to get additional um, additional rating out of the bridge. So that's why it's good to enter these as system bridges, because if you enter them as system bridges, you always have the ability now and in the future to try to get a little bit more out of the bridge by using a little more accurate 3D analysis. But generally, if you run it as a line girder and everything rates okay, then there's not necessarily a need to run it as 3D.
Yes, exactly. Thank you for adding that, Mark. Yeah, when you run when you run the line girder analysis, it'll use the AASHTO distribution factors, or you can define distribution factors, and in cases where, exactly like Mark said, if you need to try and get a more, I guess, precise or refined analysis, that's where the 3D can be used. Or in cases like if you have, let's say like a curved girder bridge where you just need to do the 3D finite element. Okay.
Yeah, do you see the question there, Carolyn, asking about bearing and transverse stiffeners? So do you want to
Oh,
answer that? Do you need them both?
let me just look at this here. Get stiffeners, you need to find both the bearing and transverse stiffener for BrR to consider the web stiffened at the end panel. Do bearing stiffeners count as transverse stiffeners? Let me see. Off the top of my head, I think that if you have bearing and transverse stiffeners defined, the program will look at, the spacing of all of those stiffeners when it's making the determination of, whether that girder is treated as stiffened. Um, if you ever have a situation where you're not sure how the software will treat that, I guess actually, you know what, I'm glad we mentioned this here before we go to members. Okay, a couple of things I want to point out. So I guess the short answer is I believe the program should look at both of those types of stiffeners and the spacing of those stiffeners to make the determination of the stiffened end panel. But I want to just quickly, because this reminds me, I want to point out a couple of places where you can find more information here about these. So when you're in the bridge workspace, if you click this this top left tab here in 7.5, it'll take you to this like backstage page. In version 7.6 and newer, there's a help tab up here, and so you can get to that through the help tab. But here you want to click to the backstage, and then you can go here and select the analysis that you're looking at. So for this, we were looking at AASHTO LRFR, and then you can double click and you have this method of solution here. So this is very extensive, detailed explanation of how the program handles different situations and how the finite element model is built, and how all of the spec checking is done. So you'll see this is 745 pages. So a lot of information in here, but just the quick overview is that this goes through how it sets up the finite element model, and then applies loads, runs the analysis, and then later here through the document, there are basically flowcharts for all of the spec checking. And so basically you can come in here and, search the PDF for the thing that you're for, anything you may be looking for. And it'll walk through the steps of the things that it's taking into consideration when it's doing those checks. And so I wanted to mention this just because there are, I think, a lot of questions like that when you're going through and setting up these bridges as far as like, how exactly is it using some of this input? And so this is a really, really helpful resource whenever you run into questions like that, to basically try and determine like, is this particular input used for, for some of the different things that are happening in the spec check. So this is definitely a really important resource. So I just wanted to point this out as well. And then, like I said, I think the shorter answer to the question you asked is that I think the program should be considering all of the stiffeners. Alrighty. Actually, and then the other thing I wanted to just mention too, is, as we're working through here, we do, aside from the method of solution, and I've mentioned this in the other trainings as well, but just to reiterate, there is also the F1 help window. This will tell you a little bit more about kind of specifically what each window is looking for, and kind of what some of these different things it's asking for actually are. But when you have questions that are more, when you run into things where you're more like, exactly how does this get used in the spec checking process, that's where the method of solution would probably be more helpful. So just wanted to point those couple of things out. Alrighty. So we will go ahead here and create the member alternative. So we'll select steel and plate girder, and that will give us the member alternative description window. Set the end bearing locations, and we will add an additional self load for this. A couple of other notes on this window. I don't think we have, I don't know that we have to, I don't think we have anything that we need to change for this example bridge. But again, just to point out, if you wanted to, if you did want to like run a different spec version, again, this can be helpful in kind of comparing, results from maybe a specification from around the time the bridge was built to the current specifications or things like that. You can make those adjustments in the specs window. We also have condition and system factors here. We're not going to do anything with the engine tab or the import tab, but the control options tab here basically includes a number of different options and alternatives for analysis. So I would suggest referring to the Iowa DOT documentation and standards for the templates and review those control options. Again, if you're creating a new bridge from scratch, there is engineering judgment that comes into how you want to set these up. But I would recommend reviewing the Iowa DOT templates, in addition to for new bridges that you're creating. So for this example, what we're going to do is just uncheck the must consider user input lateral bending stress, because we're not entering that for this example. And aside from that, we don't have any other changes we need to make here. So we'll go ahead and click OK, and that creates our member alternative. So let's see. so once we've created this member alternative, you can see again that this is defaulting to now this girder 2 has an existing and current alternative, and it defaults to the one that we just created. All right. So, and you can see the schematic here is updating as well. So we're going to go ahead and define the girder profile here in this window. So we'll just take a minute or two here to go ahead and enter the web and flange information for the girder profile.
Carolyn, there was a question about what the difference is between existing and current. Do both need to be included in that member in the analysis?
Good question.
So I think the first thing to do in this situation, Carolyn, is to once you're done with this window, you can go back to that window and we can hit the F1 key and read the definitions from the help.
Yeah, and this
That's-
is something that definitely can be a little bit confusing with the existing and current. Let me.
The naming of it is going to change, I think, to something more intuitive down the road. This has been a debate for a while. We're just not sure what to call it.
Yeah, this has been discussed quite a bit, and even somewhat recently we've this has been brought up as being sort of confusing.
And then Carolyn, we can also after we read, I think it's good to start off with the definitions, the official definitions, then we can also expand on that a little bit.
Okay, so I entered the web there. I'll need to go back and we'll pick back up there in just a minute. But yeah, so here we'll go to the member window and go to the F1. Because like I said, this is definitely can be a little confusing. Okay. So so sorry, were you saying something?
Yeah, so if everyone had a chance to read that existing and current, just leave it up there for a second, and then we can kind of talk about it.
Yeah.
Okay.
So I think I
Good,
do
Carol.
actually.
What was that?
So, okay, so this is definitely, I think, can be a little bit confusing here, but so we're saying the existing represents like the existing member, and this will be used for batch analysis. So like we were saying, with the bridge alternatives, it's important to have the bridge alternative so that it knows what to rate for batch analysis.
Well, Carolyn, can you close out the help for a second here, and let's talk about a couple scenarios. So it's beyond just the batch analysis. If you close that out, and then cancel out of here for a second.
Mhm.
When you do a line girder analysis of this bridge, so if you scroll all the way to the top, like when you click up the very root, all the way at the very top, right there. Okay. When you go ahead and do a line girder analysis, it actually will use the bridge alternative and see how you've constructed your bridge, and then it will actually call into the individual structure definitions based on how you set them up. And then it will actually start to do a line girder rating on every single member. And then it will take the controlling, obviously, whatever's the controlling component on the bridge, that will become the rating factor for the entire bridge. What you can actually do is, let's say you have a 4 girder. Let's just make this real simple. Let's say you have a single span 4 girders. If you uncheck the existing, then it will skip that during the rating. So let's say that you have a case where you only, for whatever reason, you only want to load rate 3 of the 4 girders. You can unmark one of them is existing, and it will only load rate the 3. Now the danger is that you could be skipping crucial components of your bridge, so you have to use that with caution. But there are scenarios where you would want to do that. A lot of agencies will make multiple, like as over the lifespan of the bridge, they will every time they do an inspection, they'll copy the existing member alternative and mark the new member alternative as the existing one, and they'll keep the old member alternatives there so they can kind of maybe track the history of that member or that component. Like for example, if they want to see how deterioration has changed over the various inspections, they can go back, and so the existing one will only rate the newest version. Sometimes you may put a temporary girder in there. Let's say there's some damage or something that was detected and you want to simulate that. That's another reason why you would want to do it. Now, we're not showing right now on Carolyn's screen here, we don't have a schematic of a single member. This is the cross section for the entire structure definition. But if you were looking at like a member schematic, one of the schematics that are on the member itself, if you click on like G1 or G2, and you're trying to look at the current it'll use whatever the current member is for drawing the schematics as an example. If you go to the member alternatives, then it will draw that member alternative.
Yeah.
But that's really what those things are. My recommendation would be always keep those two things in sync until you're comfortable switching them. Always keep them in sync. And again, you can always uncheck the existing if you want to have it skip the analysis. But again, it will skip the analysis, so you could be risking getting an incorrect rating.
Yeah, exactly. And
Tanner, yes. I mean, in a way, you could think of it that way. Yeah, the current is just, it's whatever, like it is basically, yes, let me just, for all intents and purposes, yes, to answer your question, yes, it's the graphical toggle. I've been on this project for 15 years, and this goes back before my time, so I don't know all the history about it, but my speculation is that people had multiple member alternatives, and one, like let's say under G2, you had multiple member alternatives, and one of them was the real one that you wanted to rate, and so you mark that as existing. But people wanted to be able to switch the schematics to view other member alternatives by default, but they didn't want to lose whichever one was the current existing because that information would be lost. So that it got split into two checkboxes. Does that make sense? That's my speculation on why it was like that. But my recommendation is to keep them in sync.
yeah,
Sure.
thank you, Jeff. And yeah, I think the existing and current thing is definitely probably one of the things we get the most questions on. But like Jeff said, I think good recommendation is to keep them in sync, but you do want to make sure that they are selected. And again, they will, like, if you're creating a new bridge from scratch and you create this superstructure definition, the first member alternative that you create will default to being the existing and current member alternative. So you wouldn't really need to change that or mess around with it. But again, in a case like where you have, like, let's say an as built, and then like you want to add an alternative with deterioration and keep that, then that would be when you would want to change those to make sure that it's set to the correct one.
Okay, and there was a question about diaphragms, and I think I understand your question, but just to be clear, I put a picture in the chat. The 3D models aren't really grillage models, they're actual 3D models. So this image is out of the method of solution manual, and you can kind of see you do have some control over the the elements that are generated. So for a steel girder, a 3D analysis, the top and bottom flanges are modeled as beams. The web is modeled as shell elements, and so is the deck. And then there's a master slave connection between the girder and the deck itself. So it's not really, so when you're connecting your diaphragms, you have the option to connect them at the top, the bottom, I think, or in the center. So Carolyn has the one of the images up in the on the screen share. So I'm not sure if that answers your question, but when you're defining the diaphragms, it does try to connect them at the top and the bottom if you have a cross frame diaphragm, and it's all dependent on how many shells you have defined in your analysis settings. Matthew, I don't know if that answered your question or not.
But yeah, also Mark, just to reiterate, yeah, we do not currently have a grillage analysis in BRR. I think we may add that at some point because it's kind of like a nice step in between a line girder and a full 3D, but we don't currently do that.
That's correct.
Yes, thank you guys. Yeah, and then just to mention again as well, the image that that Mark put in the chat there comes from the Methodist solution here. So again, you can get there by clicking this bridge workspace in the top left. Come in here and go to Methodist solution, and this will, I believe this is where, yeah, this is the same image there that we have in the chat, and you can skim through this as well, uh, just to find some more information about that. Although I think you guys summed it up really nicely. So, um, all right. Any other question? How it models cross frames to top and bottom flange both to the model based on the input and based upon the top of diaphragm. Okay, I'm just looking. We have another question here. Again, relating to how it models cross frames to the top and bottom flange, both to the model based on the input and based on the type of diaphragm. So in the I just opened up the diaphragm definitions window here. So there are different types of diaphragms that can be selected. And so how it models.
Oh, I see. I see what you're saying. So you're saying if you just have a beam, how does it model? How does it model that? And I think it tries to put it. Let let me get an answer for you on that because I think it tries to put it in the middle. Um, the the shells that get distributed. If you say you have three shells in a web, it's going to do three equal shells. So it has to connect it somewhere to one of those nodes. It's either going to be at the top or in the center. And I kind of forget specifically how it does that for just like a beam diaphragm or a single diaphragm. So unless you know the answer, Carolyn, you can let me try to find that while you continue on.
Okay, yeah. Yeah,
I can check that real quick.
okay. Yeah, that would be helpful. Thank you. Um, yeah, I'd have to look back through the Methodist solution and stuff a little bit. So I think Mark will take a look at that and we will get you an answer on that. And I will I'm gonna continue setting up this girder profile here. All right, so we had entered the web information, and we'll go ahead and do the top and bottom flanges. Right, we've got the girder profile set up. One thing I'm just thinking about here a little bit too. So for this, this tutorial really is sort of centered around kind of the line girder analysis. We do have other kind of information and tutorials that are focused on more on 3D analysis. So, you know, if that would be helpful, we certainly could do that at some point too. All right, so we set up the girder profile. We can see that updated in the schematic. Well, the next thing to set up here is to go ahead and create the deck profile. And so this is where we are defining the structural properties of the deck. I had mentioned before when we enter the deck thickness in the typical section window, this will be used here for dead load. When we're entering the deck profile here in the member alternative, this is used for the structural properties. And there is also this compute from typical section that you can use. And so this will also compute these if you want to do it that way. So you'll see in this example, the structural thickness here is 8 inches, and the deck profile window is 8.5. So again, that's just difference here from structural properties versus dead load properties. And here we will go ahead and enter the deck reinforcement. And then we'll use the shear connectors window to just define the composite region. All right, so the next window here, we're going to be defining the haunch profile. And this will be used for in a composite section for the offset for the beam and deck. And then just to keep in mind with this as well, you know, a lot of the time you will have a haunch, I mean, almost all the time you'll have a haunch profile that varies over the girder. So this is used to, like I said, compute the offset between the beam and the deck for structural properties. If you have a case where you know, it varies, but you want to use, let's say the smaller haunch, you can always like add in additional member loads in the member loads window. So, you know, if you wanted to kind of be on the more conservative side, use the smaller haunch and then add additional member load. Um, so, so then next we will just set up the lateral support ranges. So for this bridge, the half flange lateral support will be over the full length beam. And then we have the stiffener ranges. So for the stiffener ranges window, you can use the new button to create new locations. You can use this apply at diaphragms. And this will allow you to select the stiffener definitions that you have and click OK, and it'll populate those for you. Then we can click OK to save that. And then we will set the bearing stiffeners. So we can see when we said apply at diaphragms, these are populated here. All right, so then once we've got the girder profile and deck and everything set up, we can go to the live load distribution tab. For the Iowa DOT template models, what you'll see that these distribution factors are not populated because they're computed at runtime. So in this window here, when you're creating a new bridge and you go into the live load distribution, if you leave these blank, the distribution factors will be computed at runtime when you run the analysis based on the AASHTO distribution factors. Additionally, you can compute and save them in this window if you want to save those to the bridge model itself. You can also look at how they're being calculated here as well. Sorry. On. All right, so if we click compute from typical section, it will populate these factors, and you can look at the view calcs button. And so this will show you how these distribution factors are computed and the references to the AASHTO equations that are used here. So you can review those, and if you do have like an unusual case where you wanted to manually enter distribution factors for an unusual configuration, you can just directly enter those here, and it'll override the values that are there. But so for this example, we'll use the computed AASHTO ones, and we're gonna save those to the bridge, and so that means those distribution factors will be used whenever the analysis is run. Like I said, if you leave these blank, they'll be computed at runtime. All right, so we've got the girder member alternative set up here. If you right click on the plate girder member alternative and click schematic, we can also view a schematic for the girder profile that we've just created. Let me just make this a little bit bigger here. And so you can use this to just kind of, verify and review input. So this will show the plate sizes and lengths here for the flange and web transitions, as well as the stiffener spacing, composite ranges, and, deterioration if that's entered as well. So we can review the girder profile here. Okay, so so that covers setting up the member alternative for that girder. Just a couple of things to note briefly. Once you've set up one of these member alternatives, you can copy and paste it to the other ones. So we went through and did an interior girder here. And let's say for this bridge, you wanted to, you have 4 of the same girders. You could right click and copy, and then just paste this into, the member alternatives for the other members here. The one thing that I want to point out with this, though, just to be careful about when you do that, is if you do compute and save your live load distribution factors, you'll want to go through and recompute those. Especially if you're going from like an interior to exterior girder, or if there are different spacings between the different girders. So just keep in mind that, if you do compute and save these distribution factors, those will be carried with the member alternative, if they're computed and saved. So if you're copying to another girder, you'll just want to make sure that you either leave those blank so that they can be computed at runtime, or come in and recompute and save those so that they, reflect the correct spacing and like location for that girder. A couple of other things to note just briefly. So the other couple of windows that we have here are points of interest and deterioration profile. We've covered some things with this in some of the other trainings, as far as entering deterioration, whether it's through the deterioration profile window, or using points of interest to override different aspects of capacity to reflect the condition for that girder. So we're not going to go through that in depth here, but those are discussed in other trainings. So once we've got this member alternative set up, we can go ahead and run an analysis here. So, basically you'll want to select the member alternative that we want to rate, and go to the design rate tab, open up the analysis settings. And for this example, we're going to use this LRFR design load rating template. In general, you'll be working with the Iowa DOT models. So Iowa DOT has their own analysis templates. So you'll want to use those. For this example, we're just using the HL93 design load rating. So once we've opened that, we can click OK. That saves our analysis template. And then with this girder selected, we can go ahead and run the analysis. I'm just going to make this smaller here so we can see the analysis progress while this runs. Oh, hold on. Okay. I may have missed entering something here. Let me go back and double check. This is telling me that I entered something incorrectly for my stiffener here, which certainly looks like I did. Give me one moment and I will update this. There we go. So I missed the stiffener width. And so what the program is telling me is that it needs that information so that it can run. So let's try that again. We'll go back here, click analyze, and there we go. So this shows the analysis progress. And you can also skim back through here. You'll see a few different things that are warnings or informational messages. And so, it's always good to look this over if you're getting these messages. Again, on a lot of the warnings, it's going to be fine. Like in this case, for example, it's just mentioning that it needs ADTT for fatigue analysis, but again, good to look those over. All right, so once we have run the analysis here, we can go into tabular results to review the analysis results. So this will give us the live load type and the rating factors and controlling locations and limit states here in the tabular results. Then we can also review these specification check details. So, for example, when you have tabular results and let's say you look at the tabular results and you see that you have a rating factor maybe that's lower than you might expect, you can take a look at where the location is that's occurring. The next thing you'll probably want to look at is to go into the specification check details here. You can expand this and you can go to that location. And so you'll see all of the AASHTO articles that are checked. These ones are informational. These ones are the green and red ones are pass fail. And so this will show you, what's working and what's not. You can open up these articles and basically read through. It'll show you all the values that it's using and computing. And so that can help you to determine one that you've entered things the way that you intend to, and that the program's using the values that you think it should be. And then it also provides references to the AASHTO spec references that it's checking for the analysis. So let's see. You can also review the engine outputs here, and so this will also provide a summary as well of the spec check results. So with that being said, I think that we have covered creating this structure. Again, this tutorial goes through the creation of just this single interior girder, but like I said, you can copy those member alternatives to the other girders. Again, just be careful if you've saved your live load distribution factors. Again, and then obviously if there are, differences in those girders. And so those then all kind of go into the superstructure definition itself, which is then assigned to a bridge alternative and then can be used for batch analysis when you're running this bridge from the Bridge Explorer. So with that being said, let me see if we have questions or anything.
We do have some answers on the connection of the diaphragm. If you look in the chat, and I'm getting an answer on the type 4, but the connection, and let me just share my screen for a second, Carolyn.
Sure.
In the method of solution manual, we have a way that these are the type 1 diaphragms, and this is if you have 1 or 2 shells, it connects the cross frames at the top and bottom directly to the beam elements. If you have 3 or more, it does, there's a description here of how it decides where to connect it, and it will actually move the nodes and the shells in the web based on the user input. Now the question was about the type 4 diaphragm specifically. And there is, I think I pasted it twice, but there's user input for the Y location of the type 4 diaphragm for the A and B connection. So it could be partway down the web or at the top or bottom, and you can measure it from the top or bottom. And I believe it does the same type of thing depending on how many plates or shells. If you only have 1 shell in your web, it's going to attach it either at the top or the bottom. If you have more than that, it'll attempt to attach it at a midway point. And I'm getting somebody to verify that, but I believe that's the way it works. So I think that's the answer to your question, Matthew. If it's not, we can do a follow-up after the meeting. But if you generate your model and you look at there's a 3D model viewer graphics, and if you look at it, you can see exactly where the diaphragm is being attached. And again, it's dependent on whether you have 1, 2, or 3 or more plate elements in the web. So hopefully that answers your question.
Thank you, Mark.
You're welcome.
All right. Let's see if we have any other questions. Just looking through the chat here. All right. I'm looking through the chat here. So yeah, as far as follow up on the diaphragms, I do see another question out here. Yeah, please feel free to follow up with our support, right, Mark? Yeah. Okay. Perfect. Yeah. Jeff just put the support email here. So the questions that we're discussing here with the diaphragm model, we will follow up with you on the support here. And then again, okay. Yeah. Sorry, I'm just looking through the chat here. I want to make sure we're not missing any questions or anything.
And just to add on, you had said it's not modeling flanges and webs separately for type 4. It is modeling webs and flanges separately. So the flanges are modeled as beam elements and the webs are modeled as plate elements. So I'm not sure if I was clear in my explanation of that, but the beam is comprised of beam elements at the top and bottom for the flanges, and they're connected with web elements, which are plates in between. So they are being modeled separately. But anyway, if there's follow up on that, Matthew, yeah, please submit it to the email that Jeff pasted in the chat.
Yeah, and just to, I guess also just to just one other thing to mention on this with the diaphragms and the finite element modeling, for the vast majority of these bridges that that you'll be doing here, you probably will not need to run the full 3D finite element analysis. What's being discussed here with the diaphragm modeling and the elements used in this model here does relate specifically to the 3D. So for the purposes of just the tutorial that we did here, this is really focused kind of on the line girder analysis. You know, we're certainly certainly happy to follow up on any of the 3D stuff as well. But just to avoid any confusion, is that for the majority of the time when you're modeling these bridges, you will be able to run line girder analysis without modeling those. So alrighty, so I'm not seeing any other questions here. So I think that covers everything that we had here for this training. Sean, did you have anything else that you wanted to add or anything?
I just wanted to add that for the templates, we made certain decisions for our steel templates. I think Carolyn mentioned we have the control options that you may want to use for them and other things like that. But there are some decisions we made that you may disagree with for your own model creation. And one of those that I just want to touch on is linking versus not linking your members. We decided to not link the members because we thought for the templates it'd be easier for you guys to take a template and adjust for deterioration or something specific. But you guys may want to consider linking your members if that's something you're confident and comfortable with. So that was just one thing I wanted to bring up. I don't remember how in depth if you guys talked about linking members at all. If you want to explain that a little bit again.
Sure. Yeah. Yeah, I'm glad you brought that up. Thank you, Sean. So so when you link members in BRR, basically what it'll do is let's say for this bridge, if you go into, so we created girder 2 here, and then I copied that over to girder 1. Let's say for girder 3, I can go in here and say link with girder 2. And essentially what I'm doing is you'll see that completely disappears. So essentially what you're doing is telling the software girder 3 is exactly like girder 2. So there's no need to do an additional analysis for it. So when you run that analysis, it's going to analyze this girder, but it's going to treat this as being identical. And that's the girder properties, loads, distribution factors, everything. So you don't want to link them unless they really are identical. But in cases where, let's say you have a whole lot of girders across a cross section and you want the analysis for that bridge to speed up and you don't want to repeat that analysis, that would be one case where you'd want to link those members. Like Sean said, in the template models, these are not linked, and the reasoning for that is so that you do have that member alternative for each of these, so that if you're adding loads, adding deteriorations, you have all of those actual members there. So yeah, but there is the option to link members here if you had a whole bunch of truly identical members.
Thanks, Carolyn. So that's all I had to add. I don't see any more new questions yet, but I'll let the group go. And if anyone has anything in the last couple minutes, I'll stick around and you guys can feel free to ask more questions. So thanks, everybody.
Thank you.
Thank you all.